So we were doing chemical kinetics and today's topic is rate law expression. Now in order to understand rate law expression, first we need to understand what is rate law. Representation of rate of reaction in terms of concentration of reactants is known as rate law. Now before understanding rate law expression, first we should know how to write down law of mass action. According to this law, at a given temperature, rate of the reaction is directly proportional to the product of molar concentration of the reactants. Suppose we have a reaction A, B, C, D. So according to law of mass action, rate is directly proportional to product of molar concentration of the reactants raised to its stoichiometric coefficient. Removing this proportionality sign, we will get a constant. This constant K is known as rate constant or velocity constant. Now, rate law expression. Now, if you want to write down rate law expression for the same reaction, then according to this law, rate is directly proportional to product of molar concentration of the reactants raised to some power which may or may not be equal to its stoichiometric coefficients. Here we have used the power x and y which may or may not be equal to A and B, that is stoichiometric coefficient of that reaction. So removing proportionality sign, rate is equal to K A to the power x B to the power y. Further, rate can be written as dr by dt is equal to K A to the power x B to the power y. This equation is known as differential rate equation. Now talking about difference between rate of reaction and rate constant. Number one, as we are well aware of, rate of reaction is the speed with which reactants are converted into products, whereas rate constant is proportionality constant in the rate law and is defined as rate of the reaction when the concentration of reactants is taken as unity. So rate is equal to K molar concentration of reactants. So if the molar concentration of reactant is taken as unity, then rate constant is equal to rate of that reaction. Second difference, rate of the reaction depends upon initial concentration of reactants, whereas rate constant is independent of the initial concentration of reactants. Third, units, moles per liter per second. Here, units depends upon order of the reaction. Order we need to understand. We'll understand just now. So now let's understand order of a reaction. It is sum of the power of the concentration of reactants in the rate law expression. So if we have rate is equal to K A to the power x B to the power y, this is rate law expression. Here x and y indicate how sensitive the rate is to change in the concentration of A and B, and x plus y is equal to n, where n is order of that reaction. Order can be 0, 1, 2, 3, nth. So now let's understand how we can find out units for rate constant. Again, using this same equation, K is equal to rate upon a to the power x, b to the power y. Rate, concentration per unit time. Again, A and B, these are molar concentrations, and X and Y together becomes N. So we will use this formula to find out units for rate constant of different reactions. So let's find out units of rate constant by using this formula. Reaction, order, units. Number 1, zero order reaction. Order is 0 here. Now units. For concentration we will write moles per liter. For time we will write seconds into. Again for concentration we will write moles per liter. Raised to the power its order, that is 0. Anything raised to the power 0 is always 1. So units will be moles per liter per second for zero order reaction. Now for first order reaction, order is 1. Again concentration, moles per liter, time, second, concentration, moles per liter. Now this time the order is 1. So these two will be striked off and unit will be per second. So for first order reaction, units of rate constant is always per second. Like this, we can find out units of rate constant of different types of reaction like second order, third order and nth order reaction. So please find out units of rate constant of these different types of reaction.